Yep. Good evening. Come on, let's start off. Last class we have finished with elasticity. We'll be starting off with electrostatics today. First we'll finish off electrostatics and then we'll do gravitation. Then we can go for waves, I guess. Let's see. Again, electrostatics is quite a high weightage topic. Electrogravitation, this Gauss law, and after that all the things that come in entire electromagnetism is a bunch of almost 33% weightage. That's 1/3 of the physics. And still now how much ever mechanics we did, pure mechanics is around 25%. But then again, without mechanics, you're not going to learn anything. Others, do keep your cams on. So let's start off. So first thing, what's electrostatics? It deals with interaction between charges at rest or slow-moving charges. So when the charges move really fast, all kind of things start happening. We'll not get into that. So during this phenomena, right, we neglect any magnetic and relativistic effects. So when our charges move, they also create magnetic fields. Because of that also there'll be forces. We are ignoring all that stuff. When we do magnetism, we will see how moving charges create magnetic fields. And relativistic effects, when things go really pretty close to speed of light, the masses get affected, time, length, everything gets messed up. We will not get into that stuff again. So first thing, we hear a new word called charges. So what are these charges? So charges are of two types. Positive. So whenever we say positive charge, we think about a proton. The value is given by plus 1.6 into 10 power minus 19 coulombs. Coulombs is a unit. Whenever we talk about a negative charge, others whose cams are not on, and next minute I'm going to remove you from the classroom. This charge is minus 1.6 into 10 power minus 19 coulombs. Now, understand here, the sign simply indicates they're of different nature. They have nothing, meaning you can't say the plus 5 coulomb is greater than minus 5 coulomb. This thing has no sense actually. This doesn't make any sense. It's like saying, plus 5 meters is greater than minus 5 meters. Plus 5 simply and minus 5 indicates the direction. Clear? Have a look at this page. So the first thing is there is something called a charge that is actually creating all these electric and magnetic fields. Next thing. So properties of charge. So what does this charge do exactly? If your electrostatics is good, gravitation becomes quite easy actually. The only thing that is different in gravitation is the extra part is satellites. Other than that, so gravitation chapter goes quite fast. Because in gravitation, everything is only attraction. Whereas in electrostatics, you study both repulsion and attraction. So it covers up. So the first thing, in an isolated system, charge is conserved. Meaning, if you have a system here, let's say it has 5 electrons, and let's say it has some 10 protons. After some time, electrons will combine with protons and they become neutrons. So let's say some 3 or 4 electrons combine. Let's say we got 3 neutrons. Now we have 2 electrons and we have 7 protons. Now, if you see here, the number of charged particles will change. So number of charged particles are not conserved, but charge is conserved. So they can ask a question like this. In a system, the number of charged particles are constant, not necessary. Charge is quantized. You'll keep hearing this word a lot. I'm sure the first time you heard this thing is, where did you hear this word? You heard it in chemistry. The energy of a photon is quantized, angular momentum is quantized. So the word quantization meaning, think of like this, the smallest denomination of money that we use right now is 50 paise. That means if I say I gave you some money, I can be sure it is a multiple of 50 paise coins, isn't it? I can't give you 83 rupees 27 paise. I can't give you 37 rupees, 19 paise. So whatever I give you must be a multiples of 50 paise coins. So any charge transfer is a multiple or integral multiple of electron charge. That means if there is a body there and if you say I gave charge Q, I can be sure this Q should be n times E, where n is an integer. But lately people did actually found particles even with a fraction of electron charge. We'll not get into that because these things are not commonly available. When these people started bombarding, protons together in this hadron collider, they observed, all kind of weird, 1/3 of an electron charge, 2/3 of an electron charge. People did find, fractional charges. But then again, we are out of the scope right now. We'll not get into that. So that is the meaning of quantized. So whenever you hear the word quantized, that's what it means. You can always get an integral multiple of marks. For example, the marks you get in the exam, if you see are multiples of 1, you can never score 92.5. You will always score 94s or 95s. Or think like this thing. Let's say you're writing an exam and there is only +4 and 0. There's no negative marking. Then if you see your marks are quantized by a factor of 4, isn't it? Your marks are always multiples of 4. You will never get, 3, 7, all these kind of things. Your marks will be always, we can be sure, it will be multiple of 4. So it's like quantized. If you have an exam with a +4 0, it's quantized. That's the meaning of the word quantized. Play with this page. The only headache with, henceforth, all the chapters, right? The one problem will be like what? Unlike mechanics, it's difficult to visualize. When I say the ball is rolling, you can visualize. But when I say charge is there, you have to trust me. So that is the only issue with the magnetism and stuff. It starts feeling like, It's very difficult to show you stuff and all also. Next thing, you'll get used to it. But I'm telling you again, electromagnetism is quite a heavy weightage topic. Like charges repel, unlike charges attract. This is your standard school class stuff. Now, if you've seen all these things, right, one thing must notice. We make statements, we never prove it. That's how science works. What you do is you see a lot of observations and you make statements out of it. If you ask why they do that, no idea. If you can figure it out, you'll get a Nobel Prize. So free electrons are responsible for charge transfers. That means when you say a body is positive charge, doesn't mean you give extra protons. So when you say the body is positive Q, what it means is someone actually removed electrons. So protons are fixed inside the nucleus, you can never move them. So when you say a minus Q charge, meaning you gained electrons. So basically protons never move from the nucleus. So the thing is initially, right, someone actually started with the concept electron is negative charge. That's the headache. Technically, if you had written electron as a positive charge, life would have been more easy because we define current as flow of positive charge. So later on, people actually realize the electrons are the ones actually who are moving and everything. But then again, by then we already printed books and changing things is expensive. Like I keep saying this, most of the things we do are for convenience. The most powerful subject in the world is economics. No one gives a damn about science. If you can make enough money, then economics will work out for you. Fifth one, charge is independent of velocity. So if you see, actually mass and all do get affected by relativistic effects, but not charge. So for example, we have a mass by root over 1 minus v square by c square. This is a relativistic mass. So m naught is your rest mass. This is the mass when velocity is 0. C is the speed of light. Now, why this happens is a different story. We'll not get into this. But yes, mass does get affected. That's why, studying a vehicle going on a road and studying an electron going is completely a different thing. Have a look at this. Clear? Any doubts so far? Next thing. So when you keep saying this charge, how do we actually get this? So there are three ways you can create charge on a system. Can I turn the page, Vidyut? Yasha, go ahead. Kushagra, go ahead. Am I pronouncing your name right? Okay. Ali, Anika, clear? Great. So there are three ways. Charge can be created on a system. One, by friction. So if you take two materials and rub them, you must have done this in school. You take your comb and rub it to your, the hair and put near the pieces of paper. So whenever you rub two bodies, electron, and two bodies are rubbed against each other, silk and silk cloth and a glass rod are best. In case you didn't get a silk cloth, a cat is also good. Silk cloth and a cat also will work pretty well. Cat ka skin, if you see, it's pretty nice. Only thing, just meaning if you take two cats and if you rub them against each other and leave, then they get attracted. That would be interesting. But yeah, force is negligible. So if you have two bodies here with mass m and mass m, so initially they have a lot of electrons. So both are initially neutral. So when you rub them against each other, so they can ask a question like this: if two identical bodies are rubbed against each other and they're placed in a weighing balance, it's negligible, but mass does change. So the one who becomes positive charge, mass will actually become m minus dm because the electrons have gone from here to here. That's what I'm saying. Whenever you say positive charge means you didn't gain positive charge, you actually lost electrons. This guy will become the equal same charge. This guy mass will gain by m plus dm. There's a slight change in mass. The total charge is still constant. The second thing is by conduction. So when two conductors are brought in contact, charge transfers till the potential becomes same. Just like if you bring two containers with water together, the water will flow till the heights become same. So if you take two identical containers, let's say if this guy is plus 3q and this guy is minus q, and the moment you connect the switch, this guy will become total charge is 3q minus q is 2q, so plus q and plus q. I'm taking identical, so the charge will divide equally, but if they're not identical, we'll see how to do later on. Have a look at this. My friction by conduction. Now, if you observe in gravitation, na, ये सब कुछ भी नहीं होगा. If you connect two masses, masses won't transfer. If you rub, to yeah, masses will change, but they don't jump around. That's what I said. Gravitation is actually more easier version of this. Yeah. Why do electrons need to jump forward when the friction is there? Uh, you're talking something else, Ujjan. Friction has nothing to do with that. So electrons, they're jumping from where to where, God. Electrons are roaming around the molecules, isn't it, along the nucleus? They're just orbiting. If you bring another nucleus pretty close, what will happen? There's a chance you can push into the other orbit. If you have a nucleus, electron is going like this. If you bring the other nucleus so far, so this electron which is going like this, there is a chance, it will go into the other orbit. It can go into the other orbit. It jumps across the orbits. That's what you mean by transfer, right? It's not like, the electron will take its bag and go to the airport and then take a train or a plane. So it's not like that. Electron is simply being pulled away from one nucleus to another nucleus. So I think when I say electron transfer, you must imagine like it packed its bags and went to the bus station. No, electrons don't do that. That would be an interesting movie, but you can make an animated movie out of it. By induction, the third one. So when a charge is placed in front of a body, it induces charge. How is that? Think of like this. So if you have a body there, if you bring a plus Q charge, imagine, you are, let's say in a classroom, I'm there, and if I bring a lot of chocolates, what will happen? All the people in the benches, right, will jump to the front and will try to take the chocolates. So the same way, all the electrons will start jumping to the front. So when the electrons are jumping front, what will happen? The nucleuses will lose electrons at the back. So like I said again, when you say positive charge, doesn't mean you gained electrons. The electrons from the right side simply got attracted. Getting it? So electrons are being pulled towards this. So this will give you a minus Q charge and a plus Q charge. The total thing is still neutral. So electrons get attracted. You've also seen this thing. Whenever there's a event for a concert or something, people flock to the front. All the seats at the back become empty. Right? Now, because of this, what will happen here? The plus Q and minus Q are closer than plus Q and plus Q. Therefore, they attract. So even though the body is neutral, they still attract because the distance gets messed up. The same way, if you had brought a minus Q charge, now think the other way around. If you take a stick and start beating, what will happen? All the people in the first and second bench will try to jump backward. That means now you will get vacancies in the front. You are repelling the electrons. So this guy becomes minus Q and this guy becomes plus Q. So electrons are pushed away from the front. Still, if you see the opposite charges are more closer, they still attract. It doesn't matter. You bring a positive charge or a negative charge in front of a, what you call the body, the neutral body, it still attracts. So that is the third way you can create a charge. Have a look at this. Now I can't show you charge, but I can show at least what it does. Did you see what happened? You can see that you have a styrofoam plate, you rubbed it, then you took this plate and kept it on another plate, they're repelled. Can someone tell me what happened? They repelled, they didn't attract. So what are all the things that are happening? So first thing, you took a styrofoam plate, a cloth, you're rubbing. This is by friction. So now when you rub the styrofoam plate with this cloth, one of them will be positive, one of them will be negative. We don't know who is who. Let's assume styrofoam is positive. So we have a positive styrofoam plate coming closer to the neutral styrofoam plate. Now when you bring in the first MC, there's no repulsion, it comes so aram se. But the moment you touch them, by conduction, the positive charge gets transferred between both of them. Now both became like charged, isn't it? Whatever is the charge of that above plate or the bottom charge also is similar charge, positive or negative. That's why they repel. You can see it's getting attracted opposite, and it is strong enough to oppose the gravity. That's the reason it took a styrofoam plate. The weight is less, and styrofoam is actually kind of conductive. So you have two phenomena here, by friction and by conduction. Clear? So both the things happened here. So you rub the rod, so that is by friction. Now see, you're not touching the can, but you're bringing it closer. This is induction. So the first thing while rubbing, you got it by friction. Now second part is induction. And this is fine. This is fun. You make a dosa there with the soap film, like a soap bubble. And you put that rod. Even the soap bubble gets attracted. This is by induction. That's what I was saying. It doesn't matter what you keep, it'll always attract. This thing. Look at this thing. You can do that thing same with the water also. So when you rub that rod and keep it close, you can see water gets attracted. So even a neutral body, which is not a conductor, if you see water is kind of an insulator, still it induces charge. All the same thing, balloons and all that stuff. This is an electroscope. This is an experiment which we normally do. So he kept this too thin, this aluminium foil kind of things. Now see initially what happened. Both the foils are sticking together, so there is no charge, anything. Now you rub the rod, so the rod has become some charge, positive, negative, jo bhi hai. Let's say positive. When you bring it to the top part, you're inducing charge. So the top part, let's say it becomes negative, then the bottom part becomes positive. Now, since both the aluminum foils are positive, they repel. Can you see how they're flying away from each other? And see, the more closer you bring the rod, the more charge you induce, so they repel more. This is how you can explain there's a charge. You can't go and see the charge. You bring close, they repel. You go away far, they come back normal. You're inducing charge. So this is basically the electroscope, basically. You can even fly a thing also. So their charge does exist. It's not our imagination. Clear. I'll post that video in the group also after the class. You can check it out. So if this was positive charge, this will induce a negative charge on this. Because this is negative, this guy becomes positive, this guy becomes positive. This and this will repel. This is what happens in an electroscope.
So how does the foil become positive? It's touching the rod, right? So it should be negative only.
Where did you get this negative charge from? Who gave that negative charge?
Okay.
This is induction, God. Why didn't you ask me the same question here? Same thing, isn't it? You're inducing charges. Because the positive is closer, yes. The electrons from here went away here. Clear? Next thing. Let's see a question. We have 4 identical spheres, A, B, C, and D. It is given A is positive. That information is there. A and B repel. B and C attract. C and D also attract. B and D also attract. What is the charges on BCD? Positive, negative, bus. I don't want the values. So we have four ABCD there. A is positive. AB attract, AB repel, BC attract, CD attract, BD attract. Hmm. Think, I'll go 30 seconds. We have one answer so far. Hmm. Now, when I say attract, na, the biggest misconception is this. You think attract matlab only unlike charges can attract. So, first thing, A is positive. It is given. Okay. A and B repel. So, there is no doubt B also must be positive. Now, you say B and C attract. So, you can attract in two different reasons. One, you could have been a negative charge, or you could have been neutral. That is also an option. For two bodies to attract, it is not necessary they should have always have unlike charges. Even if you have a charge and a neutral body, they can still attract. Now that means if you assume chalo C is negative, then C and D also attract. Now that's the problem there. If you say D is also negative, then these two will repel and these two will attract. So it becomes a contradiction. So that means if C is negative, D should be neutral. Or if you say D is negative, then this should be negative. So there are two answers for this. So it is plus plus C is negative and D is neutral, or plus plus C is neutral and D is negative. Yeah, clear. So just be careful with that. When I say attract, it doesn't mean there should always be a opposite charge there. It can be neutral body also. If you had seen the options, you would have clicked.
So by neutral, you're saying that gravity, like between the mass.
Hey, I'll punch you now. ये क्या है अभी तक induction में what all the story I wrote.
Oh, अच्छा.
तो suddenly gravity, magnetic force, alien force सब लेके मत आओ. I just taught you 5 minutes back. इतना वीडियो भी दिखाया है ना रे तुझे. Now you're bringing
Video
gravity
में I
into
thought
this.
they were putting like invisible strings and all. इतना अच्छे से कैसे मतलब दोगे?
तो magician बन जाओगे. चलो, let's see. Play with this. So it's a neutral body also can attract. It's by induction. So they attract by induction. Next thing. Coulomb's law. So if you have two charges, force between two charges is proportional to product of charges and inversely proportional to the square of the distance between them. In vacuum. That word is important. Now we will see what is that later on. So Coulomb's law actually gives you something else. So Q1 and Q2, if you have two charges with a distance r between them, so the force acting on this is F21. So the representation is force on 2 due to 1. On this guy, it is F12. So F12 will be minus of F21, Newton's third law. And this magnitude F is given by K, Q1. We'll directly jump into the values actually. 1 by 4 pi epsilon Q, Q1, Q2 by R square. We are lazy people, so we'll write it as K, Q1, Q2 by R square. Where this K ka value is 1 by 4 pi epsilon, which is 9 into 10 power 9. And epsilon ka value is given by, epsilon is called electric permittivity. Which is 8.85 into 10 power minus 12. So what does this tell you exactly? So epsilon ka significance, right? It tells you, it's like if you can see there, where is epsilon? It's in the denominator. This is epsilon for vacuum. We'll talk about that in a bit later. But for now, epsilon is a constant. It depends on the material. Now, that is there. So remember this, whatever formula we derived is for point charges. Don't apply this for big bodies. So this epsilon ka physical significance, right? It tells us let me talk about that later on better. Okay. So that's about the point charges there. So it's a permittivity of vacuum whose value is 8.85 10 power minus 12. There. This is your first numerical kind of formula there. Have a look at that. Clear? Next thing, if you look at the vector form, so let's say if you have two charges, Q1, Q2, so this force is F21 bar. So F21 bar is K, Q1, Q2 by R square, and the direction would be R12 cap. So it's a unit vector in the direction. So just remember here, a negative force indicates attraction, positive force indicates repulsion. So the signs will take care of it. If the charges are negative, it works out. Negative force indicates attraction. So let's say one charge is positive and one charge is negative. That sign is important. It tells you attraction. Positive force indicates repulsion. They're pushed away from each other. So in all the examples that I'm showing you, we always take charges are positive. The signs will take care of it if you're doing a variable. And same thing, if you have multiple charges, let's say small q, q1, q2, q3, so on till qn. Forces are, you can just do principle of superposition. You can just add them up. So if there are n charges, the force acting on this charge would be the vector sum of all the charges. Fn, F3, F1. So that is basic vectors. If there are 10 forces acting on the body, the resultant is a vector sum of the forces. See, the moment you use the formula K Q1 by Q2 by R square, electrostatics got over there. It becomes a mechanics problem. Let's see some questions and then we'll go ahead with there's a little more theory, but let's do some problems. Clear? there. So the only thing I taught you is K, Q1, Q2 का R square. That's it. Let's do something more easy and then we'll go ahead. So let's say we have a point A here, 1, 2, 3, and there's a point B here. Let's say -1, -3, let's say B is somewhere here. -1, -3, 2. So here at this point, the charge is plus 2Q. At this point, the charge is minus Q. Find force on 2Q due to minus Q. Vector form, I cap, J cap, K cap में चाहिए. Let's get this thing. Easy one. I can do one more thing actually. Let's put C also. Let's call it 3, 1, 1. And here also let's see the charges plus Q. G2 minus Q and plus Q. Yeah, that will be easy only. Let's get this. Any answers? How to do that? First, I'll show you for A and B. So let's just find AB bar. So AB bar is what? A to B. So -1, -1, -2I, -3, -2, -5J, 2 -3 minus K cap. So magnitude of AB bar will be root over 2 square, 25, root 30. You know what is AB cap. Then similarly, let's find AC bar. 3 -1, 2I cap, 1 -2 minus J cap, 1 -3 minus 2 K cap. So mod AC bar is 4 root 10. Root 9 to 3. So the force on 2Q charge will be force between these two guys, A and B. How much is that? K, 2Q, Q. Don't worry about the sign. By distance square, which is AB square. What about the direction? Now this guy is getting attracted. So the minus sign shows it attraction. So I'll just show it this way. So this direction should be BA. Yeah, you're going from A to B, the AB cap. That's it. So the sign takes care of that AB cap vector. Plus, these two guys are repelling away from each other. So the other force will be acting like this. So the second magnitude is K, 2Q. q. So just take the magnitude, directions, right? Draw it on the diagram. That would be easy. Don't get confused with that plus, minus, and all that confusion. AC square. So this vector will be, you're going away from C to A, so C A cap. Easy. And you know how to find CA cap and AB cap. So AB cap is take the vector AB bar and divide by its own magnitude. Same thing, CA cap is take CA bar and divide by its own magnitude. You can substitute, they'll get the answers. I'll leave it to you. That's how you get the vector. So just draw a diagram, you'll clearly see minus q is attracting. So that green color vector is from A to B, so it is AB cap. The positive vector is from C to A, so it is CA cap, and you're done. So get the magnitude and finish off with that. Don't worry about whether the charge is plus, minus, and all. The diagram with the force vectors will take care of it. Easy? Got this? Next one. Clear, na? Malika, got this? Parthika, Rehan, Udayan, Palak, Neil, clear with this? Going ahead. Next one. So we have a hexagon. How do I draw this? So there are plus q, plus q, plus q, plus q, plus q, and plus q. There are 6 positive charges. This is a regular hexagon side A. And here you have a charge minus q at a height of y from the center. I hope you're getting how is the diagram. This minus q is not in the plane. Minus q charge is at a height of y above the center of the hexagon. So you can choose this point as y is equal to 0. So that center is y is equal to 0. Plot force versus y coordinate. Basically, I'm asking you force as function of y. If y is small compared to a, find time period for small oscillations. SHM. Let's go. Just give it a try. I hope the question is clear, everyone. There are 6 charges on hexagon. Just give it a try. Let's be back in a minute. Any answers? Forces K, Q, A square, Y square. God, there is an angle between them. I hope you have taken that into account. Simply add तो नहीं किया ना? You just added 6 into F किया. ये बीच का, if you see the force here, this is an angle, isn't it? Everyone will attract like this ना, umbrella जैसा. So you have to take F का vertical components ना, 6F cos theta. तो cos theta भी आएगा. I think you guys are just adding up KQ1 forces directly without taking into vectors. Why? Why are you guys behaving like juniors? They do such things. Phi Q का ring. Why will you take phi Q का ring? There are 6 charges there. Why will you take 6Q का ring? But still it's an hexagon. मतलब for you, the ring and hexagon, they don't mean the same thing. You hate hexagons. You're a hexagon hater. Something like that. हो सकता है, मतलब then benzenes will hate you. They might take revenge on you. So that's all. It's a dirty expression with 3/2. Yes, welcome to life. Nah, yes, I think you got it. अभी time period भी निकालो, इतना आ गया तो. There's something even more important. ये कुछ भी नहीं है. When you plot the graph, there is something there. I want you to draw the graph. That is more important. Graph is hyperbolic. Nee re. Which max are you using, re? Utsaha, what the hell is that? How can your time period depend on y?
अरे
Time period
सर
depends on y. हाँ
सॉरी
हाँ, यही करो. एग्जाम में सॉरी नहीं होता है. -1 डायरेक्टली. देन कुछ बड़ा प्रॉब्लम नहीं है. इंस्टेड ऑफ IIT बॉम्बे गौटी जाएंगे, वहीं पे मस्किटोस मारेंगे. नहीं तो चेन्नई जाएंगे, वहीं पे समर तो टोली मेनी टाइम्स. समर हॉट, समर वेरी हॉट, समर. Let's see.
So sorry,
Oh,
but
I want
leave the mass for the second part. Like all the
मास चाहिए क्या? हाँ, ले लेना मास इज इन.
से मास
ठीक है.
चाहिए
ठीक है ना, वो सब छोड़ के दैट पॉइंट यू आर कैचिंग व्हाट इज नॉट देयर. ले लेना मास. You guys are telling exactly being like juniors. I started conducting exams for them ना. So there is one guy who scored something like 67 था. And then in the but the portal it is showing 69. He's saying sir मुझे यहाँ पे 2 मार्क का ना डिफरेंस दिख रहा है. I said idiot, there are 31 marks which you messed up. वो नहीं दिख रहे तुझे. पोर्टल में 2 मार्क्स का एरर दिख रहा है. That is your concern. I think they're still juniors ना. They are like excited about every 1 mark. सर एक मंथ रुको और सेट हो जाएगा. Let's see. I think I should ask you one more point now, then you guys will do. You're not understanding the importance of the plotting of the graph. Find y for maximum value of force. That would be a pretty good question. So if I ask you this in the exam, more than one choice questions, I'll ask you these 2 questions, B and C. At what distance y with the force is maximum? Because so now, exactly at the center they cancel out. Agreed? At infinity again they'll become 0 because they're very far. That means somewhere in the middle it is going to maximum, isn't it? That is actually what I wanted you to say when I say plot the graph. When you plot the graph now, it starts here 0, infinity 0, means it actually bumps up and goes like this. So you need to find me that point also. Because there'll be 2 graphs with the same values. Option se hoga a/2. There'll be another graph like this. Option hoga a/√2, √3/2, like that. So even if you figure out the graph, you'll get stuck with that value. Let's say the force part, then I'll give you 1 more minute to figure out that maximum. You have to do maximum in my differentiation. You guys are saying ये function weird है, differentiate किया तो और weird आएगा. So I'll just make this bigger. So if you look at the forces now, this is your force F. This is a vertical. This is theta. I'm not drawing all. So the force F का magnitude would be K, Q by that distance. This is A, and that is perpendicular root over A square plus Y square. I hope everyone is clear with that. This is just the magnitude. So the net force would be 6 times F cos theta. So that would be 6 K Q by cos theta is adjacent side, that is this Y by the hypotenuse. would be y by a square plus y square whole power 3 by 2. The direction would be downward. So I'll just show a downward arrow. It is the force is downward. That could be actually minus k cap, whatever it is. Trick कुछ नहीं है, just solve it. Big differentiation, Adrit. I'll punch you now. कुछ है ही नहीं है वो x power 3 by 2 is a big differentiation. Max में differentiation start हुआ max में. There you should have done more big differentiations. Compared to that, this is like a small puppy there. Then what? हो गया F net. We want to find maximum minimum value of this thing. So indirectly, I'm asking you to maximize this. अरे यार इतना छोटा differentiation का you guys are saying like you need a trick for this. dy of y by a square plus y square 3 by 2 इसका differentiate करना है. Chain rule. And if you think it's a big differentiation, that because you forgot. First chapter, if you go back, calculus when I taught you, you actually learned how to differentiate this stuff. देखा? I did teach you this differentiation. X by root x square plus 1. Then you saw this again, you know where? In maximum minima. You didn't differentiate more hopeless things. There is that. So there are functions which we differentiated. Okay, anyways, you got the point. It's not a very dangerous. I think this one. Dekho. See, I told you also. You will get a function like this. Question ye tha. I said there'll be two charges like this. There'll be force like this. The question was same. Find x for the maximum value of force. That is now what you say. And then we differentiated this. Then we got d by root 2. So let's differentiate this. Diagram बहुत बड़ा हो गया. So so first differentiate y. So that will be dy 1 by a square plus y square whole by 3 by 2 plus y, and differentiate that. That would be minus 3 by 2 a square plus y square 3 by 2. Then differentiate whatever is inside, chain rule. That would be 2y is equal to 0. This would be I'm getting a 3 sign now then. Minus 3 by 2 minus 3 y square by a square plus y square. This is 5 by 2 is equal to 0. So we get y is equal to a by plus or minus a by root 2. Got this? A by root 2. It's not a lot of work, but yeah, so if you try to plot the graph, now let's say plotting is y and this, just be careful. If I take up as positive, down as negative, the force is actually negative when you're in the positive y-axis. So you go up and you decrease. When you're below, the force is upward, so the force is like this. Are you getting how? When you're above the positive y-axis, the force is being pulled down. If you're below, the force is up. So the graphs, you have to be careful with the signs also. And this peak value, so it's not a hyperbola or something. It will be symmetrical graph, yeah. So this guy is a by root 2, this guy is minus a by root 2. That is how the graph would look like. So, and we know f is equal to k q q y 6 by a square plus y square whole power 3 by 2 is equal to minus mass into acceleration. A is much greater than y, so you can neglect the term. Acceleration is equal to minus 6k q by m. That would be a cube into y. That's your omega square. So time period is 2 pi root over m a cube by 6k q cube. Check. Please look at the steps. Ask me if you're confused. The moment I wrote f is equal to k q by y square, electrostatics got over. After that, it is all NLM and a little calculus. I could have done this with 2 charges, 4 charges. Hexagon is more fun. A simpler version would be two charges plus q, and it's on the perpendicular bisector. That's an easier version. The moment you see the hexagon, it just scares you. So that is an extra effect. Clear? Any doubts on this? Please ask me. This much differentiation and all, it should be quite comfortable. If you look at the last 3-4 years advanced papers, right? I'm telling you again, papers are not tough, they're lengthy. The moment you think in the exam, "Arey, itna lengthy kyun karna hai," meaning you have taken a back step. Means instead of solving the problem, you will look at the problem and you'll crib, you will complain, "Arey, itna working hai, kya paper hai, what is this, what is this?" And this is not a good sign in the exam. Because in the 3 hours of exam, if you are using some of your time to complain, you'll get frustrated. Every time you see lengthy calculation, you'll get frustrated. Once the paper gets over, you will realize in 20 questions of physics, you could have done 18 questions. You know how to do 18 questions. But 18 questions, you needed solid 1 or 5 minutes of non-stop solving. But because you got distracted complaining about how lengthy it is, you start hating it. तुझे ये lengthy लग रहा है? I'll show you one question. 2018 या 17 याद नहीं है. But advanced में there was a question, in nuclear physics. Meaning it's a pretty dumb question. Matlab, you just should know just how to add, multiply. Bus. If you know these two, you'll get the marks. And it is a paragraph. Literally 8 marks. But people cribbed, okay? Everyone complained, "Oh, yaar, itna calculation kya hai?" The numbers were like this. 1.00785 into 20, 1.00865, then you get something like this, then you get like this, 0.367221, then you have to multiply with 931, then you get the answer. बस अगर इतना कर लिया तो 8 marks था. There is a full paragraph on this. And there is nothing in the question. मतलब everyone who read the question knows like कुछ है ही नहीं, but it is solving. And in the paper, that was one of the easiest question, but people complained. So be careful. देखो numbers are bad, pretty bad. You can't do anything. मतलब literally even I couldn't write, तो मैंने actually screenshot लेकर डाल दिया सब photos notes में. Look at that number, 5 decimals, 6 decimals actually. This is what I was telling you. Or
was it, estimate कर सकते हैं?
और 6 decimal क्या estimate कर सकते हो? आंसर ही 6 decimals है.
अच्छा, सारे ऑप्शन ऐसे? ओके
सारे options ऐसा ही. You can't do any estimation there.
ओके
उसमें क्या है ना, the error only comes at a 5th decimal.
अच्छा, that's the then torture.
तो ऑप्शन नहीं है, तुझे 6 मल्टीप्लाई करना ही पड़ेगा, नहीं तो आंसर नहीं आएगा. This is what I'm shouting on your seniors also. I think last 1 month से वही काम था. Never feel like, when you see a question, never complain, "Arre, itna lengthy hai." Be happy it is lengthy because everyone else is going to leave it. Even after being an easy question. Let's see the next one. I hope everyone is clear with this hexagon. Yeah, don't do that question in the beginning. Just finish it off, rest and come back again. Or you should improve your calculation speed. See, if your calculation, you're wasting time, that is, you need to think why you're wasting your time in calculation. Let's see one more question like this. So plus q. अभी calculation speed नहीं है तो उसका क्या solution है? Figure it out. There are a lot of things people teach you, Vedic maths, that, this, a lot of stuff are there. This is mass m. This is plus q charge. Now this guy is displaced along this way. So initially this is equidistant d/2. Find time period for small oscillations. You guys need to learn, whenever you have problems, try to figure out at least, 70-80% on your own. Somewhere down the line, you guys are taught like, every problem you take a lot of guidance. Exam, when you suddenly encounter a problem, you don't know what to do. At least put a fight. Try to figure it out once or twice and then take help. That would make sense. Let's see. Hmm. Hmm. We have one answer. Anyone else? MD cube by 32. Aryan, I'll punch you. I told you multiple times. How can you get time period in terms of X? It is okay to give wrong answers. So give good wrong answers. Don't give blunders. There's a difference. Always, when you do mistakes, make sure you're doing good mistakes. Good mistakes will teach you in life. If you do blunders, you will get slaughtered. That's bad. What is a good mistake? Instead of doing, let's say, electrical engineer, instead of doing electrical, you did a course on naval architecture. You did some other weird course. That's a good mistake. You at least get to learn something. I did it. So I did a course and went on shipbuilding actually. All my friends were jumping. Arun, pata hai communication course hai, super course hai. Third year mein tha. Sixth semester. Sixth or fifth, I guess. All were saying, oh, super course, that course, this course. I said, okay, go to course. Basically, IITs mein na, there is something called free electives. You can do 5 courses, whatever you want. That you get in third year. So I said, chalo, dekhte. Then everyone, there's a big mania actually. Everyone is communication systems. So even I took first class I attended. It is full probability and statistics. I was like, what the shit is this? Like, first of all, normally only max I'm a little worried. And upar se you combined probability and statistics. After second class, I didn't understand anything. I went to the teacher and said, sir, I'd want to drop the course. Then he said, it is too late to drop the course now. Then he said, I'll do one thing for you, right? I'll give you a U grade, means I'll fail you, but I'll give you full attendance. So there's a catch. In IIT, mein, if you see grades, we have grades like this: S grade, A grade, B, C, D, E, U, W, I. S means 10 out of 10. 1 or 2 will get in the class. Everyone doesn't get 10 out of 10. A is 9, B is 8, 7, 6, 4. There is no 5. If you got U, means you failed, lack of marks. W means you failed, lack of attendance. W is the most dangerous grade. If you get a W grade, now see in IITs mein kaisa hai na, there is something called credit system. Every course has 2 to 3 credits. If you do this course, you'll get 3 credits. If you do this course, you get 2 credits. So if you have 165 credits, you'll get a degree. Now it doesn't matter which course you do and all that. So there are some certain electives. But if you get a W and if you complete 165 grades, until and unless you complete that course, you won't get a degree. You can have a U degree, you'll still get a degree. You can get a U grade and still the degree will get it. But W is the most dangerous grade. You get a W, you have to do that course. So the teacher said, yeah, I'll give you a U grade. So I will say you came for all the classes, but you failed. That way you can leave my course and do something else. I said, thank you, sir. I means we don't know what to do with you. That's a very special grade for very special people. So I got a U grade in that course. I failed. So I left that course and I went. And during that time, there's only 1 or 2 courses are left out opening. And there's one course on how to build ships and how to build coastal structures. I said, ये तो interesting लग रहा है. कुछ तो है ships के बारे में. I went and joined that course. And the teachers were so happy to welcome me. Like, oh, electrical people are coming to our course. कुछ तो हो गया हमारा branch को कर. It was a fun course. They used to show everyday video, ships ka, boats ka, structures ka. It was a fun course. Then I did one course on how to make movies. Then I did one more course on how to do fictional writing, how to write books. We did all these things I did. And so looking to कर क्या रहे हो? I said, यार, what are you guys doing exactly? Oh, probability course में सब लोग क्यों घुस गया? मतलब is it that interesting? नहीं. The professor is very very prominent, and if he gives a certification, right, a recommendation letter, that will help you to get a abroad में कहीं पे internship के लिए बहुत help होगा. सबका वो reason था, इसलिए सबको course करना था. वो छोड़ के और super course करके, they took innocent person like me and they kept me in that course. So I said, मुझे कहीं पे जाना नहीं है. Anyone else got an answer? I think Ishan, you also got it. So there, you'll have a lot of fun. Put some work, go to a good college. You'll find a lot of weird friends. So how do we do this? Minus q. So this distance becomes d by 2 minus x. This guy becomes d by 2 plus x. So this guy is also repelling here, and this guy is also pushing here. So let's call this F1. Let's call this F2. Acceleration is this way. We always take the acceleration in the direction of displacement. So F2 minus F1 is equal to ma. So F2 will be k q q. I'm not taking the signs. I'm taking the magnitude directly because the sign already took care of the direction. Minus k q q by d by 2 minus x whole square is equal to ma. You can cross multiply. Take out that k q q common. The denominator become d square by 4 minus x square whole square. If you see the numerator, that became a minus b whole square minus a plus b whole square. So that a square b square terms will cancel, and you'll be left out with minus dx 2dx is equal to ma. For small x, you can neglect this. Compared to d, it is quite small. Then you end up with a is equal to, that is 4 square to 16, which will go up minus 32 k q q x. 1d will cancel with the denominator. You get a d cube, and there is an m. Yeah, that's your omega square. Time period is 2 pi md cube by 32 k q cube. Clear? If this is an exam, I will solve even faster. And I used to be even more faster than this when I was in 11th and 12th. Easy, got the steps. SHM is back. You guys still think mechanics is hopeless? It comes everywhere. It is not going to leave you till the end. Next one. That's what I said. The only thing that you learned is k, q1, q2 by r square. Bas, ho gaya, uske baad all mechanics will come. That is how all the stories every time. Let's see one more. Let's do actually mechanics problem for fun. We have an incline. Theta, friction is mu. We have a block here of mass m, charge plus q. We have another charge q here fixed. The distance between them is x. Mu is less than tan theta. Means the block can slide. Find x for equilibrium. Let's get this.
So just X, like not X max or minimum, something like that.
Just find x, yeah. Meaning you can have multiple answers then. Then you have to tell me everything.
So like all cases, basically.
Yep.
Oh.
Right, Utsa. Just get me the equations and leave it. How many answers are there? It's not 2. Type your answer. Don't tell it out. Let others also try. What an answer. Type it out. 2 is not the answer. That is a trap. I'll show you a similar problem. 3 is also not an answer. You know where you have seen this problem? Friction. How you have seen this thing? This question, remember? Find m if the system is at rest. And I told you always, whenever you hear the word friction and equilibrium, you always get a range. Because friction ka force can adjust its value. Do you remember? Friction ka value can go from 0 to maximum. There is no guarantee friction will be always mu mg cos theta. you always get a range. This question was based on this actually. So instead of putting a block, I just kept a plus q charge to repel. The story is the same. So let's take the two cases. The x minimum, you bring the mass so close, they're repelling so strongly. How will the forces be? This would be the repulsion force, k q square by x minimum square. This guy would be mg sine theta, and this friction would be F maximum mu mg cos theta. You're on the verge of, getting pushed up. So if you solve this, you get kq square by x minimum square is mg sine theta plus mu mg cos theta. Similarly, if you keep it very far, so the repulsion is almost so weak, the body is trying to come down. So kq square by x max square. This is about the friction. That's what I said. Friction is pretty dangerous that way. Friction doesn't care about anything else. It'll just try to make sure there is no slipping there. And this is mg sine theta. So in this case, you'll get kq square by x max square would be mg sine theta minus mu mg cos theta. There, you get the maximum and the minimum value. So the answer is x value lies between anything between x max to x minimum. Anywhere in the middle, you can be in equilibrium because the friction can adjust the value. Please check. So there are infinite answers for this. It's not a single one. Easy? Clear? Take a break. Come back to 7.5. We'll continue from here. Any doubts so far? Please ask me. Okay, come back in 10 minutes.
लग रहा है वो बाहर का करेंगे.
चलो, camps on everyone. Let's get this. So we have gravity is there. Two pendulums, length L. One, they have same mass m and m, but charges are q1, q2. Length is L and L. So find alpha and beta, the angles with the vertical, if the system is in equilibrium. If the whole system is immersed in a liquid and it is observed, the angles remain same, then find the density of the liquid by density of the mass. Let's get this. A simple mains level question would be, which is bigger, alpha or beta? That would be a simple question, like which is greater? Meaning there'll be three options. Find the relation between alpha and beta. Alpha is greater than beta, alpha less than beta, alpha equal to beta, or depends on the charges. It's a 4 options hoga. That would be a decent question. Try. You got 1 minute for the first one. That's easy. Second one, we brought fluid mechanics into picture now. Wait. Second, there is a problem. I didn't teach you this. So let's not do that. We'll do that later on. The electric constant भी देना पड़ेगा. I forgot. Alpha, beta, you'll get in quadratic. Yeah, just get me the equation and leave it. That's okay. No need to simplify. Just get the equation and leave it. Let's see the first one. First of all, did you figure out both the angles are equal?
Yes.
That is an important one. Most people think, what are sir, but both the charges are different, na? The mistake you're doing is, what is the force? The force is the product of the charges. It doesn't matter how much is the other charge. So this is K, Q1, Q2 by R square. This is also K, Q1, Q2 by R square. So generally people, think, what if you have more charge, you'll get more repulsion. You're forgetting it's a product of the charges. So alpha and beta both are equal. That's the first thing. It doesn't depend on the charge ka value. It depends on mass ka value though. And if you look at the forces, this is mg. This is mg. So if you look at this angle is also alpha. And this distance is L sine alpha and L sine alpha. So directly from here, you can see tan alpha is the opposite side. K, Q1, Q2 by R square mg. But R itself is 2L sine alpha, the distance between the charges. So you can substitute here. I don't think you'll get a good equation. You'll get tan alpha sine square alpha is K, Q1, Q2 by 4 L square mg. So we need to simplify the tan alpha sine alpha. That's fine. We can leave it there. If options are given, substitute and check it out. That will be the best thing to do. Simplifying it becomes more of a max question. So the first one is easy. But it depends on the mass. Can you tell me, suppose if one has more mass and one is less mass, then which angle will be more?
The one with the less mass.
Less mass होगा.
So if this guy is 2m and this guy is m, because that mass is more, now see, both will not be at the same height anymore. This is beta, this is alpha. So that much we can say. If mass is more, angle is small. Because the 2mg will push it more closer to this thing. Mass is more, angle is less. It's closer to the center. Because the gravity will push you down. So it's more of a logical.
So how would we solve a question like this if it is 2m and m?
Then you'll get more equations. That's it. What is there to solve? You'll solve it the same way. It'll be more complex. Plus I cap, J cap, components एक solve करना पड़ेगा.
Okay, sir.
It'll become too complex plus. So
otherwise,
alpha will be greater than beta.
can we do
Ah,
it
right.
with work energy theorem? Like, but then, like the acceleration of the body will be ignored, right?
Then how will you use work energy theorem?
Yeah, sorry.
If you ignore the acceleration, means you're stopping them. So all that energy is lost. Clear? ये actual question नहीं था. The second one is the actual one. Get this. What if there are 3 pendulums now? They're suspended at the same point and they're in equilibrium. Find the tension in the string. Any doubts on this A part, please ask. This is a standard question, proper mains and bits level equation. The second is a good one. Give it a try. If you have 3 pendulums of same mass, same charge, length L, and are connected at the same point of suspension, they will repel. And it's an equilibrium. So they will form a 3D shape, okay? They'll not be in the same plane. Find tension in the string in the equilibrium. Think for a minute, then I'll show you how it looks, then I'll give you one more minute. Yeah, they form a tetrahedron. Like CH4 molecule ka structure. So if you're suspending it here on the top, it will be like this. Symmetry, if you think about it, that's the only symmetrical shape you can get in 3 dimension if all are identical. So now, so that means from here, if you drop a perpendicular, that will go and fall on the centroid of that base. O is the centroid of that. So basically, it's 4 equilateral triangles.
So how do we know that it is a perfect tetrahedron?
Okay, how do you think it should be then? You should always
If you
ask the
bring
other
the
question.
charges closer,
Okay, and then
if you bring the charges closer, it can still exist like that, no?
how?
Like the bottom base is an equilateral triangle, but the sides are isosceles.
Hmm.
Magnitude
Huh,
of the charges are same, so by that logic, equilateral.
hmm.
No, sir, the base is equilateral, वो ठीक है. But the sides can be isosceles, no? Like L, and the bottom is X. It can still balance out each other.
वो भी है what you're saying. Hmm. 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 Yeah, there is no way direct way of saying it, but actually it does form. That is a most stable configuration. उसमें क्या करना पड़ेगा ना? You have to take the distance r, and then you have to do maximum minimum and through the energy is minimum in that case. That will go actually one more step. Because see,
Energy
in the
कैसे
system will
आएगी?
always try to, it will always in a state of least energy, isn't it?
Okay, हाँ, yes.
System will always exist in a state of least potential energy. So think of
Hmm.
like this: a symmetrical shape has the least potential energy compared to any other configuration that you can keep of.
Okay.
A symmetrical shape will always have the least configuration. Meaning, if you give me three charges, the best way to keep them is equal to triangle for the minimum potential energy. If you
Yes,
give me
sir.
infinite particles, the least potential energy is when they form a sphere.
Hmm. So, but the
So
top point is not a charge, na? So
I know, but it is
also
actually
should
fixed,
be.
right? It is, yeah, but then you have to prove. So ठीक है, I think maybe I can add it up here. Let's say they form a tetrahedron. Yeah, what you're saying is true. There is no direct way to just see and tell it will form a tetrahedron.
Hmm.
You have to prove it, but it will be quite complex to prove it. I remember someone asked me this last time, and we tried to prove it, and then later on checked it out in some science forum where there's actually a big derivation of two pages. So we'll not get into that. And they actually prove it's a
Oh,
tetrahedron. So let's take
okay,
it.
sir.
चलो अभी कैसे करना है? Yeah, what you're saying is perfectly right. What if there are n charges? Then the base will be n-sided polygon. The three charges is a special case where the sides actually become equal.
So what is he saying exactly? I couldn't hear him, like his voice is low.
He is asking like where to buy this tetrahedron. मतलब where can we get this? What is the cost of this car? I'm just joking. नहीं रे. He's asking if the three charges are equal, we agree with the point A sides equal. है. This is some distance r and r. What is the guarantee that r and l are equal?
So, but like for this, like when they're in equilibrium, basically if you place a charge at the centroid, it should be at equilibrium, right? Like when it's like final, like everything is at a distance, whatever.
Oh, okay. But why do you want to bring another charge? Already there are three charges, right?
But like if you like just hypothetically place one and then you balance
It will be in
forces on that,
equilibrium.
and you
Yeah.
balance this forces on that, you can get the length, right? Whatever that.
No, but that has nothing to do with the question actually. And why you bring unnecessary one more? If you put one more charge, they'll repel more. They'll actually spread out even more.
Achha.
Hmm.
Sir, i- imagine that the charges are like really heavy.
Hmm.
उसके बाद
No,
कैसे
I got
बनेगा
your
फिर?
point. I got your point. I got your point.
You
That's
don't
what I'm
need
saying. We have to give it
enough.
a tetrahedron. You won't have enough
Okay.
this thing to form a tetrahedron. So let's assume it's a tetrahedron because we can't solve actually. Now how to get this thing? Yeah, that's a valid point. There is no guarantee it should form a tetrahedron. It has to be given. And if it is not given, it becomes too complex to solve, I guess. You'll get one more variable, na?
Charges different होते then it would have been messier.
Then तो गया है ना? Then तो गया और it is और खराब होगा. अभी देखो ना, even with three identical charges only, if I don't give it a tetrahedron, I can still can't solve.
Yeah, makes sense.
Answers for this, everyone. So how do you do this thing? Right, Anita. Form like a pyramid thing. It's a valid point. It need not be a tetrahedron. I think there's some condition for this. Okay, so this is alpha. So what is this thing here? I think given a condition, this is the most optimal condition. That's a 90 degrees there. So if you see the bases are, this is L, this will be L by root 3. The centroid divides the ratio in 1:3. So what will be the forces now? If you look at the forces on the string, so we have tension. Now, if you look at the forces on this guy, this is plus Q, this is plus Q. I think if we ignore gravity, Ishan, then I think there is a possibility of a tetrahedron. But then if you ignore gravity, if you ignore gravity, then they'll fly off actually. They'll form an equilateral triangle.
Yes.
No, gravity hona chahiye. It doesn't work. We have to give. There is no way to prove it's a tetrahedron. So this would be a repulsion F. This would be another repulsion F. And you have mg. And we have tension. Please check the forces. No, if masses are negligible, kya hoga na? The repulsion is so strong, the strings will become like this. If it's only repelling, they will form this like Y shape. Isn't it? There's no gravity to stop them. So they'll just fly and they'll become horizontal. So gravity hona chahiye, or else you won't get the shape only. Clear with this. So if that is T, how to get the angles now? We got the components here. It's more of a geometry. So this is alpha. So if you take the components here, this guy would be T sine alpha. And this guy would be T cos alpha. There, check it out. So in the vertical direction, the forces will balance. T cos alpha will balance mg. And in the horizontal direction, if you look at these forces, it's more of a vectors question once you got the basic stuff. The centroid will divide that line in the angle of 30 degrees. Don't forget that. So that horizontal tension T sine alpha will balance to F cos 30. Where F ka value is KQ square by L square. What do you want to find? Tension, no? Square them and add them. So T square would be mg square plus 2F cos 30. So that is F root 3 ka square. So from there we'll get the tension ka value. Looks like I don't need to find the alpha ka value in this case. Could I have solved it with L also? Okay, let it be. You got this point. Check it out.
So here, sir, I was thinking, even if they don't give it's a tetrahedron, we can still solve it, I think. Alpha nikal ke.
Alpha also will come in terms of R only.
No, so then we can balance something. Can we? I don't know.
ये भी R by root 3 होगा ना?
Oh, हाँ.
Alpha भी root 3 में आएगा. ये F भी R में आएगा. So you're bringing R into the picture. So now I have two variables.
Cancel R. We can't cancel
So
R.
कितना total 3 variables हो गया ना? Alpha, tension, R. But I'm getting only 2 equations, right?
Yes, so.
Third equation नहीं है. तो वही बोल रहा हूँ. Then the third equation would be like find the potential energy and then try to minimize it. We're assuming the system will always be in a state of least potential energy.
I can't imagine doing that.
छोड़ देते हैं. We'll let it be. But everyone got the diagram here? हाँ अर्जुन क्लियर ना? और डायग्राम समझ में आ रहा है ना? कंपोनेंट्स कैसा किया हमने?
Yes, sir.
Do you guys remember something like this where we did? Meaning not exactly like this.
No vector.
हाँ वेक्टर्स में वो इक्विलिब्रियम प्रॉब्लम्स में किया था हमने सब weird ones.
That came in the first test also.
This guy. याद है? 2 strings at an angle. Then I taught you how to take components of components. We did all this in vectors.
Components
there
of
was a
components is allowed क्या हमें हमेशा सिखाया गया कि that is not allowed.
no, you can take a vector ka component in xy plane, and xy plane ka component will be I cap j cap, isn't it?
Okay, then that's fine. I thought.
Yeah. Clear with this? Let's see one more. Vidyut, got it now? Let's see one more. Let's do something more simple. We have a pendulum here, length L, mass M, no charge. Time period is T1. Second thing, same pendulum, mass M, length L. This thing has a plus Q charge, and this point of suspension also is a plus Q charge. Gravity is there in all the cases. Time period is T2. Again, all the time periods are small oscillations. Third case, we have a pendulum, mass M, length L. This is plus Q, so here it is plus Q. This is fixed. Time period is T3. This is the time period for small oscillations. Compare them, meaning which is bigger, which is smaller, like T1 greater than, T2 greater than, T3, T1, T2, whatever, greater than, less than, arrange them. Let's get this. T3, think. There's a trap. So distance between mass M and also, nay, what difference nahi badega. Let's say there is some distance. I'm not asking you to calculate the exact value, na? I just want greater or less than bus. Anusha, you got that greater or lesser? Yeah, you're right, Anusha. You're right. We have one answer. Nope. Remaining Anika, Arjun, not right. Ishan, Kush, you're not right. How do we? Anyone figured it out? Nope. T1, T2 are equal gods. That's the best part. Look at the second one. The second one is a trap. When you displace this by a theta, if you have a plus Q charge here and a plus Q charge here, the repulsion will be along the string. The restoring force is still mg sine theta only. The restoring force does not get affected. So when I take torque, the tension in the string is more. Mg sine theta L is equal to minus I alpha. The restoring force is unaffected. Tension is more actually, but doesn't matter. Therefore, T1 is equal to T2. And in the third case, this guy will repel. This will be mg sine theta. So exact values we don't know, but yeah, restoring force is less. So it takes actually more time. It comes down more aram se. Therefore, T1 and T2 are equal, and these two are less than T3. Clear? Makes sense? So the second one is a trap. Just because there's a charge doesn't mean the tension will increase. You always need to check the restoring forces.
Again.
Last case में यहाँ पे भी plus Q था ना?
हाँ, अच्छा
So
होगा.
they repel ना, so it will come down more slowly.
Yes, yes.
Takes more time to come. Easy? Meaning if you actually understand, it won't take a minute, but that's a trap. T1, T2, most people mess up that part. So be careful with that. Next one. Any doubts, please ask me. Swastika, got this? Aditya, Adrit? Clear? Abhinav? Lakshika, clear now? Rehan? Perfect. Next one. This is a standard question. We have three charges, 4Q, Q, and plus Q. This distance is X. This total distance is D. All charges are free to move. This question you can't do in gravitation because gravitation always attracts.
Can you show the previous page?
Here.
Thank you.
So the question is, find the value of X and small q if system is in equilibrium. And I can also ask you, is this stable or unstable equilibrium?
So plus 4Q and plus Q are fixed now.
No, all charges are free to move.
Okay.
Nothing is fixed.
So they are free to move like in all dimensions
Free
or
to
just
move.
their own dimensions?
Free
Just
to
one
move.
dimension.
So yeah. Abhi
Okay.
think. Exam they'll give that much only. Free to move. That's it. Oh yeah. If that is the case, they'll mention. Don't worry. They're free to move only along the x-axis. Let's go. This is a standard one. Hmm, 2d by 3. Okay. Q ka value. Okay. We have two different answers. D by 3 and 2d by 2d by 3 looks more appropriate, right? Should be far from 4q, na? Swastika, check your answer. Don't you think so? The small q should be far from 4q because 4q is too strong. Yeah, 2d by 3 looks right. Most of you got it. Find q ka value also. We have one q ka value. For some reason, I'm not getting a feeling that is right. I think that is wrong, Ryotsa. Check it out. X is 2d by 3. That is right. Find the value of small q. Aditya, that is right. Try. I'll give you a minute. Right, Swastika. Adrit, you messed up. Numerator, denominator. Right, Upsa. Let's see. What about the kind of equilibrium? Figure out that also. So first thing, we will take stability of Q. if you take FBD of small q, the right guy, now I don't know whether it is positive or negative, so I will just assume it is positive. Like I said, the signs will take care of it. K q q by d minus x whole square. Anyway, in this case, it will cancel out. But we can feel it logically should be negative charge. So if you equate them, you end up with 4 by x square is 1 by d minus x whole square. So x by d minus x is 2. X is equal to 2d by 3. Now you can take FBD of any one guy. I will take FBD of 4q. And you can clearly see here that q guy is repelling k 4q q by d square. So definitely to keep it in equilibrium, this guy should attract. So q should be actually negative. That is a catch. But TK, even if you don't care about that and take the positive sign, k 4q q by x square. So this total should be 0. This will be 4 by d square plus 4 नहीं आएगा q by d square plus q by x square. So q will be 4 by 9 capital Q. The signs will take care. You just assume everything is positive and you solve, the signs will take care. The 4q net force should be 0. But we can feel it is a negative charge. Now system is in neutral or stable equilibrium. How do you check that? Think like this. If you push this little, now this is a minus charge, isn't it? If you push this little closer, the 4q attraction becomes stronger than plus q attraction. So this will just go and stick to it, right? So it doesn't come back. So what kind of equilibrium is this? Unstable. That's how you check whether something is stable or unstable. If you push it, if it comes back, it is stable equilibrium. If it doesn't come back, it's unstable. Neutral equilibrium means, what is the meaning of neutral? If you push this q, it should just stay there. It shouldn't go back. It shouldn't come back. That's the meaning of neutral equilibrium. When you push it, it just stays there. Doesn't go or doesn't come back. So we can write that thing here. If q is pushed slightly towards 4q, it gets attracted by 4q more strongly. So it doesn't come back. Compared to plus q. It's an unstable equilibrium. Clear? Huh, Palaksh? Got this? Rehan? Ali? Adrit? Got it now? Can I go ahead? Plastika? Malika? Next one. We have a clock here. 12q, q, 2q, 3q, 4q, 5, 6. So basically on the clocks, I kept charge like this. The charge is at the center here, let's say small q. Radius is r. Find the net force on the small q due to this 12 charges. Charges are placed on a clock. Equally spaced, basically. Let's go. Let's do one thing, like minus q. A simple question would be like this: the net force is between is towards 9, is towards 3, is towards 8, towards 2, is between 9 and 8, between 10 and 9, between 5 and 4, between 3 and 4. ऐसा options होगा. That would be a mains level question. What is the direction of the force? But I'm trying to find the value of the force. So yeah, let's get this. $70 इतना अच्छा आंसर आ गया रे. But dimensions not matching. God, k cube by r cube कहाँ से आएगा? That's what I'm saying. Force should be k cube by r square. You got a pretty good answer actually. Nee, you added them kya? Again, don't do that. God's vector quantity. You can't just add the forces. I'll give you a hint. See, there's a way to do this. So what I would suggest, see, anyway, the forces are vectors, they'll just go off. I will write 12 as 6q, 6q. This is q, 2q, 3q, 4q, 5q, 6q. I will write 7 as 6 and q. I will write 8 as 6 and 2q, 6q and 3q, 6q and 4q, 6q and 5q. Now, what is happening here? If you see, this 5 and 5 are in the opposite. So this 5 and this 5 ka force will cancel, isn't it? Because if you see the force, na, k, q, small q, so it's a linear function basically. Similarly, here this 6q and this 6q will cancel. Q, 2q, 3q, 4q, q, 2q, 3q, 4q, all will cancel. So what you're left out is the final answer. Question looks like as if there's a charge 6q here, there is a 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 6q, there is a 6q. Be careful, there's no charge on the 6 a.m. ka clock. So there are 6 charges on 7, 8, 9, 10, 11, 12. Does this make sense? So now it became more symmetrical. Now can you solve? Try, I'll give you a minute. Nahi Saina, that is wrong. Adrit, how did you get values, such good values? It's a pretty good value actually. Nahi aayega re aisa. You messed up the angles, I guess.
Like cos 15 वगैरह.
Yeah, cos 15 aayega. So until unless you have substituted that, then did you do that?
I only found I cap and J cap separately.
Okay. Okay, maybe that also might have worked out. So let's see.
The
हो
values
सकता है.
cos 15 में क्या can we get?
छोड़ देना चलेगा ना. That I know you guys can do. Max मत करो. Let's do physics and leave it. Just get me the components. I think some of
I
you did
got
that.
it
I
till
kept
the
Jacobs.
I got it till here, sir. ये हो गया. उसके बाद
Then इसके
there's no
बाद ही
reference
करना
part.
था. तो करो ना then. वही तो question है. Exam में where will I come? From the window and throw chitties like. I can't do that. So you only have to solve. अभी तक इतना टेक्नोलॉजी नहीं आया. I'll be putting a chip on all your heads and we'll be sitting here. Question आया तो we'll be sending answers.
Sir, I mean, there was this guy जिसका 7 percentile से 100 percentile हो गया. from first attempt to second attempt.
होता है कभी कभी. ठीक है ना, that guy will go to IFE. No, see, even अभी एडवांस में तो नहीं होगा, मेंस में also he will go and join. अभी वो छोड़ दो, अभी जो भी हो गया इसका लाइफ तो खत्म हो गया ना. Everyone will just make fun of him. फर्स्ट सेमेस्टर में he will fail and after 1 year he will drop out. तो वो कुछ इश्यू नहीं है. Karma will come back to bite you. That I have seen. And life is unfair. So you can't do anything about it. And you guys should definitely not talk about it. You guys have 20% resolution in advance. So it is unfair. So you have an advantage, take care of it. Bas ho gaya. Because when you talk something about array acha nahi hai, someone copied, they got better marks. Life is always unfair. The problem is we think it is fair. Just think about it. You go to a forest. A lion comes in front of you. What will you say to the lion? See, lion, I don't eat you. So you also don't eat me. As if lion gives a damn about you. अब कर क्या सकते हैं? That is the thing. So always count your blessings. Let's not worry about how fortunate is others, but let's always think like how fortunate you are. Imagine you're not born in Somalia, Afghanistan. Now suddenly you'll feel very lucky about it, isn't it? If it is Somalia, then all the boys will be, doing pirating now. You'll be all on the ship, going and attacking ships, navy ships, and this cargo ships. I'll be there like a tutor. हमको ship कैसा attack करना है. So I'll be taking classes on that. Just imagine if you're all born on that. For the girls, there will be special coaching, how to make bombs. गन अगर लेके आई तो कैसे लोड करना है, शिप्स को कैसे अटैक करना है. सो मीनिंग दैट वुड बी द क्लासेस नाउ. Arun's pirating classes, how to attack ships and steal goods. So, but if you see, we are so lucky we are talking about physics. So you should be fortunate about it. Answers, let's see. So this guy, now you can do I cap J cap because all angles are 30 degrees. That is good. All forces are equal, so I'll just call it F. K Q K 6Q Q by R square. I'm just taking the magnitude. If this guy is F and this guy is F, this angle will be how much? 150. So the resultant will be between these two. So that will be 2F cos 75. Then if you take this guy and this guy, that is also F. That angle would be, basically the angle between two digits is 30 degrees. So 30, 30, 30. So that is 45 and 45. So that will be one more component there. And if you look at this one and this one, yeah, in this you will get this 15s and 75s. But I think some of you took 30 degrees and you got the answer. That also works out. So the final answer would be 2F cos 75 due to the outer ones, then 2F cos 45 and 2F sin cos 15. Is there any way you can write cos 75 plus cos 15 कुछ कर सकते हैं क्या? So think about it. I don't know. That would be the net force.
Cos C
You can
plus
simplify.
cos D, but
तो sin 15 ये भी sin 15 हो जाएगा ना, sin 15 plus cos 15. I don't know whether you can do something, but ठीक है.
उससे अच्छा आएगा, yes.
We can factorize it.
You can factor it. So you guys are the max experts, so you guys know. So there, you get it. Clear with this? Easy question. Good one. So, but there are 12 charges, so you can simplify this by putting, canceling opposite charges ka forces you can cancel out. It works out. All clear with this? Great. Next one. Now, if you take the force, what happens if you keep the charges in a medium? So the Coulomb's law actually gives you this. The formula is Q1, Q2, 4 pi epsilon m r square. So this F is the force on each charge. This is quite different from what we did before. So this we can write it as force on each charge. So when I say force on each charge, we're talking about net force. I'll tell you what is happening here. So net force on each charge is 1 by, we can write this thing as epsilon r q1 q2 by 4 pi epsilon r squared. So what is this quantity exactly? This epsilon medium is nothing but epsilon r into epsilon naught. So epsilon r is called relative permittivity. Remember, we defined epsilon naught is for a vacuum. So what does this exactly mean? The meaning of this is higher the value of epsilon r. Think about it. Where is it? It's in the denominator. So higher the epsilon r, more difficult, or you can say the more difficult for the charges to interact. That's not the exact word, but yeah. Because if you have more and more epsilon r, the force, if you can see, the force actually decreases on them. It is something similar to resistance. Now I need to think, why are you getting this resistance? So this epsilon relative is nothing but epsilon medium by epsilon naught. This is always greater than or equal to 1, right? And for vacuum, we take it as 1. So if you look at this thing, the net force on each charge, this is actually 1 by epsilon r. This is the force in vacuum. Means if you keep the two charges in a vacuum, the force on each of them will become actually 1 by epsilon r times the force decreases. Now we need to see, why does the force decrease? When you put two charges in a medium, why is the force decreasing? That we'll see in the next page. So this is the Coulomb's law for previous page here. Clear? Now, why is this force decreasing? Think about it. If you keep a plus Q1, let's take a simple example, Q1 and Q2, and you're keeping this in a medium. And we discussed in the beginning, whenever you keep charges in a medium, they induce charges. So that means this plus Q1 will induce charges here. It is actually inducing in every direction. This is also inducing minus charge here. It is also inducing everywhere in the medium. So it's not a uniform distribution that entire charge is just placed everywhere. Now see what is happening. This Q1 and Q2 both are pushing each other. So this guy would be K Q1 Q2 by R square. That is fine. But what is this induced charges doing? The induced charges are attracting it. You're getting what happened? The reason the force is decreasing is because of the induced charges. So whenever you keep two charges in a medium, the induced charges mess up the whole force. So the net force, which we are calculating, the net force on the charge is nothing but force between charges plus the force due to the induced charges. So whenever you keep charges in a medium, they induce charges which actually affect this. And the net force is nothing but what? F vacuum by dielectric constant epsilon r. So this is the force between the charges. That is nothing but force in the vacuum. Now think about it. The force between the charges does not depend on the medium. For example, let's say there's a person A. If person B is pushing with 100, person C is pushing with 20. What is the force between A and B? 100, right? A and B ka force doesn't care what is C doing to A. But what is the net force? 80. You get the point? Just because you introduced a medium, the force between Q1 and Q2 will not get affected. So you have to be careful with that word. And this is the force due to the induced charges. I'll show you an example. So the force due to the induced charges, basically the surrounding medium. So this is nothing but the surrounding medium ka force. Is given by minus F vacuum 1 minus 1 by epsilon r. Be careful. This is valid only if the entire region is filled with medium. You have to fill the entire region up to infinity with, technically up to infinity with the medium. If you just keep little medium, this doesn't work. quite a useful one.
How does this not work if only a little region is like filled with medium?
Charges won't be uniform, Nare, meaning you won't get the same distribution, isn't it? In this case, the plus charges will be at infinity.
Acha,
Getting that?
okay.
In this case, the plus charge is at infinity. If you have a finite medium, plus charge aa jayega. Whole thing gets messed up.
So what if there are like
Suppose
different mediums? Matlab Q1 is in some other medium, Q2 is in some other medium.
forget about this formula. It doesn't work. Then you can't use Coulomb's law
How do we
actually.
solve that?
We
Then
can't
how do
solve
we
that.
even solve all those? Okay, we
We
can't.
can't solve that. Why do you think you can solve everything? That's the problem. It's like thinking I know everything. Think about it. Kinematics, we can't even solve with air resistance. Can't solve. That's why we do a lot of approximations. Previous page, this one. Yeah. So what if it's a plus and minus? Now what happens? This will be more of a minus here. This will be some. This will also try to put a minus, but that will put plus, so they will cancel off, and this will be more of plus. Now see what is happening. These two guys will attract, but this time the induced charges will be this way. That is the reason the force will decrease here also. It doesn't matter whether you put like charges, unlike charges, the force will always decrease. These guys will neutralize off. These charges will go off actually. Getting this? Whether you have a plus plus or minus plus doesn't matter. So the reason why the force decreases because of the medium. Now, how will they frame this question in the exam? See, I'll show the page. Just look at this example. They will say we have two charges Q1, Q2 in vacuum. Force between them is F. Now, if the charges are immersed in a medium, force epsilon r is equal to 5. This thing is also called as dielectric constant. There's another name for this. Dielectric constant or relative permittivity, same thing. Okay. Now the question is, what is the force between the charges? Force on each charge. Force on the charge due to the surrounding medium. What are the answers? This concept now, if it is advanced, so you should do like this. But what I observed, right, exams like CET and all, they don't give a damn about all these things. They never have this concept on. They'll always say answer is F by 5. What's the force between the charges? By putting the charges in the medium, does the force get affected?
No.
So this is still F only. What's the force on each charge?
F by 5.
That is F by 5. This is what Coulomb's law gives you. That is the reason in the beginning when you see now, when I wrote Coulomb's law, I wrote that specifically that word in vacuum, because in vacuum there is no medium, so it works out. So this formula actually which we are writing now, F is K Q1 Q2 by R square. This is actually a formula for net force on each charge. It's not force between charges. Then what's the force on the charge due to the surrounding medium?
4F.
4 by 5. Yeah. Is this clear, everyone? I hope you're getting the classification. Force between charges, force on each charge, force on the charge due to the surrounding medium. All are three different questions. So logically, socho na, if two charges are there at the same distance, why will their force between them will change? Because you brought another guy from somewhere. What changes is the net force, isn't it? If I push you with 100 and someone is pushing with 20, my force on you will still be 100. I don't care what the other guy is doing. Clear? Okay. So with that, we'll wrap up for the day. So on Friday when we catch up, we'll continue from here, and then we're going to do electric field and stuff. And then yeah. And you also seen SSM advanced paper is online. It is there till Saturday night, so make sure to give. And next week we are on a break, so next week there'll be no exam also. So, okay. So do take a break. If you're planning a vacation somewhere, go, because after that you will get slaughtered anyways.